Okay, so for the next talk, everything you wanted to know about malware researching and how to get started.
Not everything, but
By Evgeny Kulakov.
thank you. Thank you everyone for having me here. So my name is Evgeny. I try to now it's okay. So I try to explain you how, if you want, you can try and become a malware researcher. What you should do about the matter, and where to start, what to expect from all this malware research stuff. Because in the news, every time it's very interesting, but day-to-day work, it depends on the man. So let's start. So basically, I will introduce myself and why and who am I. So you should hear what I have to say in any case. I'll try to explain what is malware research, what it has to offer you, and you have to decide it's bad or good individually for everyone. What you should expect from day-to-day job, and what skill sets you have to develop if you don't have one. We'll just peek into technical stuff like what tools I use during day-to-day work, and what you should learn if you want to start doing it. We'll check about several books that you should definitely have on your bookshelf if you want to do start to doing malware research as your career, and some blogs where you can have a taste how it looks like to do the research on various levels in the beginning and very advanced research that people are doing. I'll also show some malware sources, so if you want to see how a real malware actually looks like in the real life, you have this opportunity right now. And I show you some malware-oriented courses that you can take. And we'll finish with job offering examples, like for a junior malware researcher and experience plan. So I started my my professional career as a software developer. I didn't have any malware research or security research skills at all. I was doing software development and team leading in image processing team. And then at some point, I started to think what to do next with my life. I hopefully know now, but you know, it's this question always comes to you back in every couple of years. So I started to think about software security. It was cyber. It's cyber today, but back then there is no such word at all, except in the Hollywood movies. It's like it was 2011 back then, and I didn't think about security at all. So I created some sort of a list. What's very important for me in a day-to-day job. at least for the 5 years ahead of me. And with that list, I started to search all possible career opportunities that was introduced. HR didn't even know what reverse engineering is and what malware research is and who even can be employed in such positions with them. But surprisingly, software security was a field that answered on most of my bullets in that list, and I started to look for available position. And I was lucky, so I found a reverse engineering job with zero experience in reverse engineering. And I was even ready to have my salary cut, like at least in half, just to get into this field. I was ready to on anything just to get into the field, so I have very big ambitions, and I started to work in Transteer. It was, and it is right now, security company which have a product for anti-financial fraud. It was several years ago acquired by IBM, but back then it was a startup, very successful one, and I started there with zero knowledge, as I said. So this is my story, and I think I have some things that I can share with you, and most of them are applicable today, and most of them you can actually use today because we are living different times. Cyber is everywhere, and it's very easy to find, if you want to, it's very easy to find a way to enter this field. And from there, it's like, if you know to swim, you can get everywhere. So let's talk about what malware research is. I will not talk about pros and cons because everyone will decide for himself. But it's basically a cat and mouse game. There is practically no winners or losers. And it's good and bad because you also have some work to do, and everyone shares the market in every side. You also need to learn a lot of stuff, and everything changes pretty frequently in terms of techniques that are used, in terms of software security products that are pop up and startups that right now you can see on pretty much all over the place. And you also have to be ready to hours of wall hitting because the thing is, in malware research, you are the one that's supposed to know how to crack this stuff. Because of this, you're doing this research. Nobody else knows what to do with it. So either you have your peers that you can ask and find someone to talk about, but in many cases you are working alone and you trying to solve this by yourself. It's a good and bad, depending on your personality. Financial compensation is relatively high. In many cases, people just cannot afford at the first interview to pay you this amount of money, but I think eventually they will. This is basically because of the shortage of skilled personnel that you can have you see on the market, and we'll talk about why. At least. It has a very relatively small but strong community all over the world, and eventually you get to know pretty much everyone who does some similar to what you are doing, either from conferences or from personal acquaintances or from research that they are publishing. You will know all the basic and figures. And in many cases, if you need any help, you can always ask if your company permits to do it. You know, knowledge sharing is not very good in security community, at least in the era past BBSs and all the hacking groups. But it also it's full of creative people, people that don't really think, let's say, regular people, because of the nature of the work. and you will, and that doesn't bother, and they pretty much enjoy share their knowledge wherever they can. It's developing any tooling. In most cases, they all want to share it through the open source projects. So you have a lot of sources to learn and advance your skill set. You can also, so malware research is basically one of the fields in security research, and you have also a different other specialization that you can have. Basically, vulnerability research, exploit development, they are not the same thing. Hardware research, security-oriented software engineering, you can basically shift if you don't want to do malware research further. But the problem with it is, in many cases, you have to invest in pretty significant amount of resources to do the shift. Because, for example, if you want to do vulnerability research, and you've never done it before, let's say you have to invest 60–70% of amount of effort that you invested before that when you started to become a malware researcher. Because of the amount of information you have to understand and the new tooling that was created and you was not aware of it. But I know people that are doing this. One of my friends in first year is actually doing it right now. He started to do vulnerability research and is learning a lot of stuff from zero ground. But he also, but the funny thing, his compensation did not change. It only went up. So at least in this thing, you're okay. So as regarding to job titles, you have several of them. So threat analyst is most likely the basic guy who's dealing with threats on a higher level. You can find them on SOCs, tier 1 support groups. Then you have threat hunters that also doing threat intelligence gathering, basically for companies' own protection or its clients. In many cases, they do not dive very low level and doing very low stuff. And then you have AV or malware analyst or researcher. You can find job titles as a way. And this is more technical role. What should you expect from your day-to-day job? So basically, you have, it obviously depends on the company you're working for. But in many cases, if it's a network company, you will be expected to analyze network communication, extract protocols, extract all the command and control servers, whatever, and all this to enhance company products. You also will should expect to deal all the to crack all the evasion techniques that malware authors are using to make your life harder. In terms of malware internals, in most cases you will try to understand, or you should try to understand what malware is doing, because the thing is, on the other side, there is not a lot of groups that are capable of developing malicious software. And in many cases, it's a business. So many people are just buying already developed family of certain malicious toolkit, and they are reusing it all over again in different places. It's like a subscription. Depending on the companies that you are working with, you have different perks like support forums, phone support, updates, whatever. And it also divided on the other side on different things. And for example, if you are working with financial malware where you're stealing money from regular people from their banking accounts, some of the guys are responsible for obfuscation, so the malware will not be detected. Some guys are responsible for how you actually make the victim think that his account is okay. So someone is basically doing this research and trying to present the good world, and while your money are stolen. And other groups are basically responsible for infrastructure. But it's another topic. You also have, if we get back to the job thing, you also have an incident response. It's basically incident response means that someone get hacked, and you are there to help understand what happened, how much, what was stolen, and who will lose their job. You will try to explain what purpose of the sample, if you can find the sample at all. You'll try to understand. You will try to gather some forensic data from the machines, from the network, and eventually try to analyze it. Most of this, most of this, you also have on-call job. So if you like action, this is probably the way to do it. Because it gets to the extent of you have a bunch of people that are residing in the US, and you have incident on the other part of the world. So they are boarding a plane and flying to help resolve the case. So more likely you will find this kind of job in consultancy services, like Mandian, but high top tier consulting services. But eventually, all the top tier incidents deal with big companies like Symantec, McAfee, FireEye, stuff like this. But in general, incident response is very different from regular malware research. So you should decide for yourself what's more interesting for you. And we also have a more advanced research. It happens most of the case in big companies because of the amount of effort, personnel, and financial stress that must be taken into account to actually conduct this advanced research. Example of such groups are great. It's from Kaspersky Lab, Flurry, it's FireEye division. Unit 42, it's from Palo Alto division. Most of them are doing advanced research. And by advanced, I mean like they are studying APT campaigns. They're following them. If you have see some blog post or white paper about the APT attack, in most cases, it will not stop there. Security companies will eventually follow over years, even after the groups, and in many cases, you will not see any reports because in most cases they will be secret, top secret in many cases. So what you see is like tip of the iceberg. Okay, so this is basically about how the job is looking on a daily basis. No, it's very picky. Everything is more a very large spectrum there. So for the sake of this presentation, just to give you understanding what we're talking about. In terms of skill set, to be a professional in this area, you have to understand a lot of things in terms of computer architecture, how everything is working in terms of CPU, the memory, peripherals. You should start to at least at the beginning to understand how Intel architecture is doing. And today we see ARM is like a next step because of natural proliferation of different kinds of mobile stuff that you will see, and I think in the near future the demand for ARM analysis will only increase. And the best source of this information are all the architectural manuals that are actually available for free from all the manufacturers. Like Intel have a set of books. They're not really readable, but but you should expect to back to it occasionally, and with years it will be less and less on your list, because everything will be in your head. But it's very interesting. I don't know who wrote them and for whom, but I think they had some sort of cooperation from guys that are writing like assembly books, and CPU is selling CPUs, and all the other guys are writing books. Everyone is happy. In terms of programming, you should definitely know to program in assembly, and you will know it one way or another if you will be doing this kind of research. You should understand how compiler works, because what you are seeing eventually is not what the programmer wrote, but what compiler generated. So at least me, from the beginning, I was thinking, okay, who even writes this? Because then eventually, when I started to see the source codes and understand how compiler works, I can understand that nobody. So you definitely have to be proficient with C, C++, because most of the malware is written with this language. Again, we have to understand that malware is a regular software project. There is no magic there. They're using the same software development techniques, the same design. You're just looking on the wrong stage, okay? So to see how C++ looks on a binary level, let's say on an assembly level, I can say it's not very pleasant. It's not very pleasant to both in your ID. And you definitely have to know Python, because there are a lot of tools that are developed, and most of them are developed with Python. And you should get familiar yourself with. You will, if you don't want to invest it right now, but you will eventually. Also, you need to try to develop at some point code injector, a P parser, a kernel driver, a shellcode based hello world. All this basically to understand how the technology works. Yeah.
It's P parser.
Okay, sorry. It's a P parser is basically executable file that we are executing. Sorry for that. It will be basically the files that you execute on Windows. It's just a file with some sort of auxiliary information. So B file is a format like JPEG or GIF. Okay, P just explains the operating system how to execute your application. So all this you need to develop not to become a malware developer, but to get yourself familiar with all the techniques, all the low-level stuff, because the only way to understand how things works is to hit the wall. Okay, and if you will try to do several of them, you will definitely hit several times, several walls. Another thing is OS internals. You definitely have to invest in understanding general operating system architecture, how operating system works, starting from general design, understanding how it works with file systems, how it works with memory, with networking. Then you also have to understand different things for file formats that the operating system understands. Then you will definitely will need to have some knowledge of code injection technique that malicious software is using to actually hide itself. Because if you know when you start a program, you can actually see it's running at a certain point. But you don't want your malicious application be seen by your victims. So code injection is a technique to inject your code, like place your code somewhere, for example, other processes, to do the stuff you want to do. For example, if you have Notepad, so everyone has Notepad, it will be okay, but it will not be okay if you start communicate with other sites like command and control server. But if you are just a regular user and you will see a Notepad running on the background, so it's okay, probably someone opened it, no big deal. So to do this, malware authors are using code injection techniques to hide it. You also have to prepare yourself for a lot of undocumented stuff, and undocumented stuff, I mean you don't have any information about what is happening, and one of the ways is to understand is to find other researchers like yourself and read their blogs. Today it's more convenient because a lot of people go public today with all the research for PR purposes. So it will not be very tough to understand very slow level stuff. But at some point you will have to research by yourself because the other side is doing the same. And you definitely have to start with Windows because this is a common platform and many information is available for this operating system. But definitely we'll see that the dark side is moving to Android, Linux, Mac OS platform, so this kind of stuff. Also, in your skill set should be networking and crypto understanding, at least to understand how protocols are working, like TCP and HTTP stuff. At least general understanding of packet analysis, because at some point you will capturing a real network traffic, and you will try to understand what is happening there. Other researchers are also sharing network traffic that they've captured for as a hobby. A lot of hobbies out there that are just doing malware research because it's very funny and a lot of interesting stuff happening there. Another thing is reverse engineering. It's not only starting in assembly. Okay, because I met some people that think that if you open like a debugger and see assembly and understand what's written there, so you are a reverse engineer. It's not like this simple. It's pretty tough skill to have, and you have it needs a lot of practice and self-learning. Today you have already books on this subject, but like 5 years ago, you don't have anything. And you should have a lot of persistence more than any other thing, because without persistence and patience, you will not succeed. You will succeed to get to some basic level, but not where all the interesting stuff is happening. But you also have to clearly understand what is it that you're looking for. Otherwise, you will go different directions. Like if you hit on the wiki page and just start reading something, you will pretty fast understand that you're reading another page that is not the original one. This is what's happening to me. And you also should have some brain power to do this. Otherwise, it will be very tough. But eventually, if you master it, it's like turning on a god mode, really. Yeah. In terms of tools, this is basically all the tools you will see or need to do your job. So basically, we have the debuggers, programs that help to analyze other programs while they are running. With this kind of debuggers, you can see like every instruction that got executed. You can analyze its memory of the process, understand what it's doing. And then you have disassemblers. It's applications that are able to can take a file and convert it back to assembly, and at some point they can also convert it back to source code. So IDA Pro is a de facto tool for doing this. Sandboxes are basically a product, a framework, which is able to analyze a sample of malicious code securely. File formats and memory analysis frameworks as more advanced stuff. In terms of books, I have several books here, and I really encourage you to have every one of them, because it's like different stages of your development, and you will definitely start to look in every one of them, different stages of your work. So the first book is Windows Internals. It's like a Bible on how Windows works in all aspects of operating system. You cannot read it like on daily basis, but you definitely will find answers to most of your questions. For example, if you want to understand what is a process, you can definitely go there, and it will be explained how it works. You will have to reread this chapter several times to actually understand fully what is happening, but you will understand what is going on. And process is not an application, just applications that you double click on your desktop. So another book is Practical Malware Analysis. It's also like a de facto book on the subject. And I can tell you, if you take this book and you finish everything, you do and read everything that was written there, you can expect to find your a job in the malware field. So it's a manual. It's very good one, because we were training several of new guys that were coming to different companies that I was working for, and we were tasked them at the beginning to study different chapters from these books, and it really helped to get them to do their work pretty fast. Another thing is the IDA Pro book. It basically explains how to analyze, how to use IDA Pro as assembler, and it's also like a Bible. It was written by one of the very respected researchers. It's expensive, but it was every dollar. Another thing, it's practical reverse engineering. It's more advanced. They have a more advanced chapters on reverse engineering there. You shouldn't start from this one if you don't have any experience in the field, but you definitely have to have this one at your disposal eventually. This is two more books. It's a bonus. You don't have to do it to have them. But one of them is a memory forensics. It's how to understand what is happening once you have a dump of your RAM in your disk. And another thing, it's a dark side book. Okay, it basically explains you how you can create a malware, how you can write a rootkit, kernel-based one. There is a lot of information there, and basically, if you also study it, I don't see how you will not be able to write the rootkit by yourself. So examples of malware results, all those are links. So once this presentation will be published, you can visit. But all those companies are basically, and the other blogs, have very interesting posts and very interesting information that you should look into if you want to be in this field. I also have here several links to a real source code of malwares. Carbit is very advanced malware family. The creators were busted like 3 years ago. Russian guys, all were arrested, I think, in Russia. But somehow someone published all the source code with like in this family, you will understand how the user mode component works, all the applications that you are running, and you also have there are some source code to understand how kernel-based components working. Kernel-based components are very rare and very tough to find, and this family actually shows you full stack. Timba is another family which is basically created in pure assembly. So if you want to understand how to write software assembly, this one is definitely, it looks good, it's very documented, and you should read it if you're interested. And Rovnix, it's a very famous kernel rootkit. There's a lot of novel ideas there, also a lot of documentation where I can understand how things work, how malware authors are thinking when they're developing this stuff. And several sources of to bootstrap your career. It's open security training. It's a course that was created by a security guy, where it takes you from very basics like what is assembly, how it works, how looks the application that you just created on the assembly level, and it works you from there to very advanced stuff like how kernel works, how virtual machines are working, etc. Very, definitely encourage you to look into this because they have like videos, they have a classroom information, like homework, various slides, very interesting talks. You should. It's also there is a link for how you can create yourself a small lab at your laptop. Never execute a real malware on your machine. On the machine of your father or mother, definitely encouraged. But this thing explains you how to set up your private research lab. And you will pick them. There are various words how, and it will explain how to set up virtual machines, how to set up networking, how to capture traffic, how to pass the real malware into virtual machine and work with it. And you also issued some Lena 51, it's a very famous set of exercises from very basic to very advanced. But it's basically on terms of cracking, how to crack software, which is also fun. So here I have two positions, real ones. First one, it's experienced malware researcher. You can see main duties and experience and skills that are desired. But it's less of interest right now. What is more interesting is this security position where a company is looking for a junior malware analyst with like zero knowledge, and they provide internal courses for onboarding guys who want to be in a malware research field. And as you can see, there is no experience required, but only desire. For what we were talking previously, the only thing they want is that you want to learn. If you want to learn and you want to enter the field, you definitely can do it today. So that's it from my side.
Not a question, but a comment to anyone who's interested in going down this malware research. There's a course on Coursera called, I pulled up, it's malicious software and the underground economy. I've been through 2 rounds of that course. The first round and the second round when the professor made a number of revisions based on feedback, and he continues to revise it, goes through an actual situation with a botnet that they did. And then part of the labs are really good practice in understanding how a lot of everything that was talked about tonight, how they go through the process and how you sandbox and everything. A really good place for someone who wants to get started to see whether this is something you'd be interested in doing or not. And then from there, you've got all the resources, the other resources. It's a really interesting course if you can get past the professor's accent.
It's still Italian guy?
Yeah.
Thank you.
Any other questions?
I have a question. You think that the knowledge of data analytics, machine learning is becoming more relevant in the skill sets of to become a researcher?
Yeah, I think the next step on IT evolution is data analysis and big data analysis. But big data analysis is basically algorithms to analyze the data. I think if you want to do data analysis in the security field, it can help because you will know what data to generate, how to generate it, whether it will be helpful to generate it, and if you know also the algorithms in data analysis, yeah, it can be helpful.
Thank you.
Okay, we're going to take like a 5-minute break and move on to the other lines.
Yeah.